Okay, so let's unpack this. We're doing a deep dive today into something pretty intriguing.
Yeah.
How do solar panels actually fare in places that get a lot of rain?
Yeah, and we're looking specifically at Columbus, Georgia. It's a great case study because you've got sun, sure, but also, well, quite a bit of rain.
Right. And you might think that's just a problem. But what's fascinating and what we really want to explore is how cities like Columbus are maybe turning that challenge.
Into a real opportunity. It's about innovation, energy independence, working with the local climate.
Exactly. So our mission is to explore, rain's actual impacts, the good and the bad, on solar efficiency, look at the clever tech that's popping up,
Uh-huh.
and figure out what it all means for you if you're thinking about solar in a place like that. So Columbus gets, what, around 218 sunny days a year? Which sounds pretty good.
It is decent, yeah. But
Right.
you also have that frequent rain, the humidity.
And that's the first hurdle for most people,
Right.
right?
Yeah.
Thinking rain, solar panels, doesn't compute. Like mixing oil and water.
Well, yes and no. I mean, really heavy prolonged rain. Yeah, that definitely cuts down the energy output significantly. We're talking maybe a 79 to 93% drop compared to a bright, sunny day.
Wow, that's a big drop.
It is, but it's not a complete blackout. The modern panels, especially the monocrystalline ones, they're actually pretty good at capturing diffuse light, the light you get on a cloudy day.
Okay.
So even under light rain, they can often still manage, say, 10 to 25% of their normal output. It's not nothing.
But hold on, it gets even more interesting because there's this paradox, right? The rain isn't just bad news.
Exactly. It's also a natural cleaner. Think about dust, pollen, general grime building up on panels. That can slash efficiency by like up to 30% sometimes.
30% just from dirt.
Absolutely. But then it rains and washes it all off. So after a good storm, you can actually see a boost in efficiency, maybe 3 to 5% higher than before the rain.
So it's like a free car wash for your solar panels.
Sort of, yeah. In a place like Columbus with regular rain, you might actually need less manual cleaning than somewhere really dry and dusty.
Okay, so you've got this drop during rain,
Right.
but also a cleaning benefit after. How does the tech adapt to that?
Well, that's where the innovation comes in. To lessen those efficiency dips during rain and make the most of the cleaning, we're seeing things like hydrophobic coatings.
Hydrophobic, meaning water repelling.
Exactly. It makes the water bead up and roll off super quickly instead of forming a sheet that blocks light. That alone can improve light transmission by maybe 8% during light rain.
And I've heard about these cleaning robots too.
Yeah, SPCR's solar panel cleaning robots, more for larger installations, but they automate the cleaning process, and then there are bifacial panels.
Ah, yes, bifacial. Tell us about those. They sound cool.
They really are. They capture sunlight from the top surface, like normal panels, but also reflected light bouncing up onto the back surface.
So light hitting the ground and bouncing up.
Right. And think about after it rains, the ground is wet, maybe shiny, that reflects more light. There was this carport project, I think in Midtown Columbus. They used bifacial panels and apparently got an 18 kilowatt peak output. The key was harnessing that reflected light off the wet surfaces. They figured it boosted their annual energy yield by about 15% compared to a standard setup.
15% just from capturing reflected light. That's clever.
It is, but even with efficient panels and coatings, you still have the issue of what happens when it rains heavily for days. Or it's just thick cloud cover, intermittency.
Right. The sun isn't always shining, especially not consistently in rainy periods. How do you guarantee power then?
Storage. Energy storage is absolutely fundamental here. On a large scale, you see utilities like Georgia Power investing in big battery facilities. There's a 65 mW one near Columbus, I believe. That helps stabilize the grid.
For homeowners.
For homeowners, pairing your solar panels with a battery system, usually a lithium-ion these days, is key. Good systems can provide, say, 72 hours of autonomy, enough to ride out most prolonged rainy spells using stored energy.
Okay, this tech is definitely impressive. But let's talk money. What does this mean for affordability? Is solar actually viable for, the average person in Columbus?
That's the crucial question, isn't it? And the economics have changed drastically. The biggest factor is probably the federal investment tax credit, that 30% credit.
30% off the top.
Pretty much, yeah. For a typical 6 kilowatt residential system, after that credit, you might be looking at a net cost somewhere between, say, $16,000 and $21,000.
Okay, still an investment, but much less daunting.
Definitely. And local installers are reporting payback periods getting shorter, maybe 8 to 12 years. After that, the electricity is essentially free. The monthly savings can be anywhere from like $44 to nearly $190, depending on usage and system size.
Plus, there's net metering, right, where the utility pays you back.
Exactly. If your panels produce more power than you're using at any given moment, that excess power goes back to the grid. And under net metering, the utility credits you for it, often at the full retail rate. It effectively turns your meter backwards sometimes.
So you can significantly cut or even wipe out your electricity bill?
That's the goal. And we see it working. Look at projects like that North Columbus solar carport or the Solarize Columbus program.
What did Solarize Columbus do?
It was a community bulk buying program. By getting a whole neighborhood to sign up together, they negotiated lower prices, cut costs by about 20%, apparently. And participants were meeting around 75% of their household energy needs with solar.
Strength in numbers. That makes a lot of sense.
It really does. And looking ahead, the tech keeps improving. Georgia Tech researchers are working on something called perovskite silicon tandem cells.
Okay, that sounds advanced. What's the idea there?
It's a hybrid approach, layering two different materials to capture a wider spectrum of light. They're aiming for something like 33% efficiency, especially under diffuse light conditions like on cloudy or rainy days.
33%. Wow.
Yeah, if they can get there, it could dramatically reduce that energy drop during rain, maybe cutting it down to only a 30% loss instead of, 70 or 90%. Makes those gray days much more productive.
And it's not just about electricity generation either, is it?
Yeah.
I read about combining solar with rainwater harvesting.
Right. That's a fantastic example of integrated design. There's a prototype in South Columbus where they actually channel the rainwater runoff from the solar panels.
Instead of just letting it drain away.
Exactly. They channel it into storage tanks for landscape irrigation. They found it cut their municipal water use for those areas by 40%.
That's brilliant. Solar panels providing power and helping conserve water. But are there downsides? Is that kind of integration tricky or expensive?
Well, yeah, there can be challenges. The initial setup cost is higher, definitely. You need the extra plumbing, the storage tanks, and integrating two systems adds complexity to the design and maintenance.
Makes sense.
But the long-term savings on water bills can be significant, especially if water costs are high or in drought-prone areas. And it reduces the strain on the city's water system. So often, it's a worthwhile investment despite the upfront cost.
This whole deep dive into Columbus, it really flips the script, doesn't it?
Yeah.
What looks like a disadvantage to the rain actually drives innovation and reveals opportunities.
Absolutely. And I think the bigger picture here is that truly sustainable energy solutions need to be tailored to local conditions. You can't just use a one-size-fits-all approach. It's about understanding the specific climate, the challenges, the resources, and working with them.
Working with nature, not against it.
Precisely.
So maybe something for you, the listener, to think about. What about your own region's unique weather, even the parts that seem challenging? Maybe heavy snow or constant fog or even intense heat. Could there be untapped potential there for clever energy solutions if we just look at it from a different angle?